Hey guys, welcome back to the channel. In this video, we'll be continuing our knowledge of rational expressions by talking about a subtraction example. In the last video, we talked about adding rational expressions, two or more rational expressions. In this video, we'll be talking about subtracting. There's similar steps, and so let's just hop right into it. Alright, so we said when we add or subtract, we need a common denominator, or also known as the least common denominator, LCD. Okay, and so pretty much we take a look at the fractions and take what they have each in common. What they need to make them an LCD. Okay, so in the case of this example today, 1 over x squared minus 1 minus 2 over x plus 1 squared, quantity squared. Pretty much what we're going to be doing is first finding the LCD. So it's best off to establish your LCD. Write it out until you can mentally do it. Me personally, I can mentally do this, but it first comes out really easier to say, okay, this is my LCD. Alright, so first thing I do is I look what we have here. Alright, so we have x squared minus 1, and we have x plus 1 quantity squared. Well, there's nothing that this fraction has in common with this one, really. So we just take the product of them. Alright, x squared minus 1 over x plus 1 squared. That's our LCD in this case. All right, there'll be some cases where we have multiple pieces that don't need to go in to the fraction, but we could cover more if you guys would like. Just let me know down below in the comment section. But pretty much, all right. So with our LCD, we pretty much now multiply 1 over x squared minus 1. We rewrite the fraction and multiply by a quantity that in the numerator and denominator, because the laws of algebra say so. Also, it's the same as multiplying by 1, so this is the same as multiplying by 1, like we would in adding and subtracting fractions. And pretty much this gives us our LCD and allows us to add and subtract a fraction. Okay, so when we're subtracting, and so this one needed the quantity squared of x plus 1 squared, and this one it needs this one here, the x squared minus 1, so it'll be 2 over x plus 1 squared, and we're going to multiply by x squared minus 1. Okay, so that comes out to be, so then we just multiply the fraction like normal. Alright, so x plus 1 squared. Alright, it's best off to leave the denominator alone. Don't expand it out. Trust me on that one. It saves time. And honestly, alright, so just multiply the numerator, 2 and x squared minus 1, and you just leave the denominator alone, times x squared minus 1. Okay, alright, so these are equivalent statements right here, and pretty much, okay, so now with that, we're going to now expand out the numerator. Alright, so there's a rule when it's a perfect square binomial. Alright, we take the first term and square it. Alright, then we multiply the first portion and the second portion of this binomial. Alright, so 2 times 1 times x, and then we square the last. Okay, first 2 times first last. First squared times plus 2 times first times last plus last squared. That's the easiest way to square a binomial. Oh, you guys couldn't see that. Sorry about that. The rule is for squaring binomials is we square the first one, add or subtract. It just depends, honestly. Oops, sorry about that. It just depends, and then we always add the last one, add last squared. Okay. Now, alright, so x squared plus 1. Alright, x plus 1 squared goes up to be x squared plus 2x plus 1. So we have x squared plus 2x plus 1 And then we also leave the denominator alone again. Don't expand it out. That's a common mistake, and if this weren't on a test, it would honestly waste your time, and it would really slow you down. These examples usually take, once you get skilled at it, about 2-3 minutes. But if you really expand, unless you are dividing out the polynomials by each other, there's no points. Then we subtract and distribute the 2, so that's 2x. That's 2x. Oh, and also so actually we're just going to say minus 2x for now. 2x squared minus 2. And we keep the denominator same, of course. X squared minus 1. Sorry about that, guys. Okay, so readjust. Okay, so now we distribute the negative to each term. Alright, this is the same as multiplying by -1. Alright, and allows us to really add fractions. So it turns this minus sign into a plus if we multiply the numerator by -1. Alright, so now we have x squared plus 2x plus 1. Alright, now positive 2x squared times -1 becomes a minus 2x squared, and a minus 1 times -2 becomes a positive 2, and we keep the denominator same. Squared. Alright, and now last but not least, we are going to combine like terms. Alright, so the x squared are in common, and the coefficient terms, the constant terms. So that's minus x squared plus 2x plus 3. Alright, so the x squared pairs up with the minus 2x squared. Oops, you guys can't see that. The x squared pairs up with the minus 2x squared. And the 1 pairs up with 2 because that's how we combine like terms. As long as their powers are the same, we could add them, and as long as their variables are the same as well. Alright, and if you guys want a refresher on that, go check out my video on combining like terms. And so we have x squared minus 1, x plus 1 squared. Okay. Now, that's it, honestly. That's it. We could factor out a -1, but honestly, there's really no point of doing that. And our final answer is minus x squared plus 2x plus 3 over x squared minus 1 times x plus 1 squared. But that's all the time I have for you guys today. In the next video, we'll be talking about multiplying and possibly dividing rational equations. So I'll see you guys next time.